So now that we have matrix vector multiplication, let's generalize it to more general matrix multiplication. So let's let A be an m by n matrix, and B be an n by p matrix. Let's let A have rows equal to R1, R2, all the way to Rm. Okay, m rows, because it's an m by n matrix. And let's let B have p columns. Let's say the columns are C1, C2, all the way to CP. And we know it has p columns because it's an n by p matrix, p columns. Okay, notice that the number of entries in each row is n, and the number of entries in each column of B is also n, because A is an m by n matrix, so the number of columns in A is n, so that means the number of columns in each row is n. Similarly, the number of entries in each column of B is n, because n is the number of rows of B, so that must be how many entries each column has. Okay, it's very important that the number of rows of A, the number of columns of A equals the number of rows of B. If that doesn't happen, then we cannot multiply these matrices. So if this happens, then the product matrix AB is an m by p matrix. M rows and p columns given by, so AB, each element is going to be a dot product of one of the rows of matrix A and one of the columns of matrix B. The entry in the first row and first column is going to be the dot product of the first row of A with the first column of B. Okay, the entry in the first row and the second column is going to be the dot product of the first row of A with the second column of B. Okay, so do you see the pattern? The row that you take from A tells you what row you're going to be in the product matrix. The column that you're using in the dot product from B tells you what column you're going to be in the product matrix. Okay, so if I take, for example, row 2 and take the dot product of that with column 1, that entry is going to be in row 2, column 1 of the product matrix. Row 2, column 1. Okay, and this would be row 2, column 2, and so on. All the way until we get to row 1 dotted with column P in this first row. In the second row, we'd go to row 2, column P. And we keep going until we get to the very last row, row M. And we'll take the dot product of that with column 1 and the dot product of it with column 2. And the dot product of it ultimately with column P. Okay. So it's a fair bit of calculation. Do understand our product matrix takes the number of rows from A and the number of columns of B. It's like the ends they have to be the same, but once you multiply them, they kind of go away. So the product matrix has M rows and P columns.